Hey guys, welcome again to the Maths Club. If you are just joining us, so welcome. This is my first video of the year, 2026, and I want to say Happy New Year to everyone, even though it's almost middle of the year. And we clocked 3 years on YouTube this month. Yeah, the month of May. That was really, really impressive how far we've come. But in this video, we're looking at trigonometry and generally, we're going to be looking at sine, cosine, and tangent of acute angles, trig ratios of 30 degrees, 45 degrees, 60 degrees, use of trigonometry tables, angle 0 degrees to 360 degrees, and the unit circle. In the next video to this, we're looking at graphs of sine and cosine and graphs of trigonometry ratios. We're going to be looking at that in the next video to this. We're going to be looking at reciprocal ratios, which is cosec, sec, cot in this video. We're going to be looking at trig identities and inverse ratios. In the next video series, looking at using trig tables, sketch graphs of trig functions, and solve problems for angles from 0 degrees to 360 degrees. That will be the next video, next two videos. So everything about graph till then, and then we're going to look at solving problems without tables using special angle values. That we'll be doing in this video. So wear your seatbelt and let's get started. So first, looking at sine, cosine, and tangent. So for trigonometry ratios, we have that for a right angle triangle with angle theta. So this is the right angle triangle. This is the angle theta. The side facing the angle theta is the opposite. The side facing the right angle, this is the right angle here, which is actually the longest side, is the hypotenuse, and the remaining side is the adjacent. So we have the opposites, we have the hypotenuse, we have the adjacent. Now we're going to be looking at something called SOHCAHTOA, which is for angle theta. Now for the SO, which represents sine, the CA represents cos, and then TOA represents tan. So sine, you see for this sine, it is OH, which is opposite over hypotenuse. This is a short form for you to actually know it, right? So if you're dealing with an angle theta, your sine is opposite over hypotenuse. So look at this, our angle theta. Opposite is line BC, and the hypotenuse is line AB. So BC over AB. So for cos also, we have CA, which is the adjacent over the hypotenuse. So adjacent over hypotenuse. The adjacent is AC, the hypotenuse is AB. So AC over AB. And then for TOA, which stands for tan, we have opposite over adjacent. So this is the opposite is BC, the adjacent is AC. So once you know the acronym SOHCAHTOA, it should be good. Now, we have this, that sine squared theta plus cos squared theta is equal to 1. How did we get this? Look at this. We know that for a right angle triangle, right? First thing, that's to be a right angle triangle, and this is a right angle triangle. We know that the hypotenuse squared is equal to the opposite squared plus the adjacent squared. Now for the hypotenuse, what do we have the hypotenuse? We have the hypotenuse to be AB. So that would be AB all squared. We have the opposite to be what? BC. So that would be BC all squared, right? And then we have the adjacent to be what? AC. And that would be AC all squared, right? Now, if I divide all through by AB squared, so I divide this guy by AB squared, I divide this guy by AB squared, I divide this guy by AB squared. So we have AB squared over AB squared to give us 1, BC over AB, BC squared over AB squared. You know, I can also write this as, say, BC over AB all squared, right? Great. Plus, I'll constant as what? AC over AB all squared. Because this guy is square square, this guy is square square. So I can just, put them in the brackets and, yeah. Put them in the bracket and raise everything by 2. So, BC over AB, you see that BC over AB was our sine. So this is like saying 1 is equal to sine squared theta plus, and then our AC over AB. Our AC over AB is cos, so that would be plus cos square theta. And this is where they got the formula that sine squared theta plus cos squared theta is equal to 1. And then one other thing that you need to know by heart is that sine theta over cos theta is equal to tan theta. How? You may have asked how, and that's very good. So let me scroll down. We know that our sine theta, at least from here, is our sine theta is BC over AB. And then our cos theta is AC over AB, right? So you can cross-check this with this. AC over AB, BC over AB, right? So if I say sine theta divided by cos theta, that would be BC over AB divided by AC over AB, right? And so if I want to solve this, I will just say this is BC over AB. This gets the inverse for me to multiply, right? Times AB over AC. So AB will cancel AB. We'll have BC over AC. And BC over AC is what? BC over AC is our tan theta. So that's why they said sine theta over cos theta is tan theta. So these are two things that you need to know by heart. Sine squared theta plus cos theta is equal to 1, and tan theta is equal to sine theta over cos theta. You need to know it by heart. Repeat it every day. Now we'll go to special angles. So these angles, they appear very well in exams, and without having to use a calculator, you can actually solve it. You know, this always makes some people say, oh, this guy finished very fast. I was able to do it. Some tricks. So it's derived from the equilateral and right isosceles triangles. And there are some key values to memorize. These for 30 degrees, but we're not going to, of course, we're not going to just take it like that. We're going to solve it and see how this came about. So if I wanted to do that, let me just reduce this. We have our equilateral triangle, right? This is 60 degrees. This is 60 degrees, right? This one too is also 60 degrees, right? If this side is 2, this side is 2, this side will also be 2, right? Because it's an equilateral triangle. And if I divide this place here, because it's an equilateral triangle, this place here will be 30 degrees, this place here will be 30 degrees, right? Because an equilateral triangle, if it's another triangle, it's not be so. And this guy will be 90 degrees. So 60 plus 90 plus 30 just give me 180. Right? If you're still confused about that, if you divide this by 2, this will form 90 degrees. 90 plus 60 is 150. Angle of triangle is 180. So 180 minus 150 will give you 30 degrees, which is this part, if you are still confused. Correct. So let's take out that half. So this piece here, let me just make this look more like a triangle. Yeah, I think this might like it. This place here is 60 degrees. This place here is 90 degrees. This place here is 30 degrees. And this line here will actually bisect this into 2 equal lines. So this is 1, 1, because E is an isosceles triangle. It is an equilateral triangle, my bad. Right. So this length here is 2. This length here is 1. So from Pythagoras, what do we know from Pythagoras? We know that the hypotenuse squared, right, is equal to the opposite squared plus the adjacent squared, right? The hypotenuse is 2, so this is 2 squared is equal to the opposite is unknown, so the opposite squared plus the adjacent is 1, so this is 1, right? 1 squared is 1. So this 4 is equal to the opposite squared plus 1. So the opposite squared is equal to 4 minus 1, which is 3. Therefore, I can say that my opposite is equal to square root of 3 if I take the square root of both sides, right? So taking the square roots of both sides. Now from this, I can find my sine, cos, tan for 30 degrees and 60 degrees, right? Because I know this guy here is root 3. And these are some values that you need to know, right? by the time you practice, just draw a triangle, This place is 60 degrees, this place is 90 degrees, this place is 30 degrees. So 1, 2, 3. You should know this by heart, right? So we'll go with 60 degrees. So sine. Okay, I'll just do, let me do something like this. So this, let me do something like this. So I'll do 30 degrees and 60 degrees. So that will help me to, instead of repeating myself many times. So this is sine, this is cos, and this is tan, right? So this 30 degrees, sine is so is what? Great, opposite of hypotenuse. So this is the opposite, say 1, this is the hypotenuse 2. So this is 1 over 2, right? So we have 60 degrees. Why 60 degrees? This 60 degrees here. This opposite over hypotenuse. That will be root 3 over 2. So root 3 over 2. For cos is adjacent over hypotenuse, which is car, right? So for 30 degrees here, where is our adjacent? These are our adjacents here. Root 3, and these are hypotenuses. So that will be root 3 over 2. And then for 60 degrees, right, our cos will be adjacent of our hypotenuse. This is, our adjacent is 1, our hypotenuse is 2, so that will be 1 over 2. Great. For tan is SOHCAHTOA. So what is tan? Tell me. Beautiful. Opposite of our adjacent, right? So the opposite here is, for 30 degrees is 1. The adjacent here is root 3. So we have 1 over root 3. But I don't like to leave surds at the denominator, so I'm going to rationalize it, right? So we've done this when we're talking about surds. So you just multiply the top and bottom by the root 3. So this is like root 3 over, root 3 times root 3 will give me 3. So our tan 30 degrees is what? Root 3 over 3. So this is root 3 over 3. While our tan 60 degrees, which is opposites over adjacent, right? This opposite is root 3, adjacent here is 1. So our tan 60 degrees is going to give us just root 3, because it's root 3 over 1, which is same thing as root 3. So with this, you already know, without even pressing your calculator, right? You can already know that your answers are correct. These are some tricks that make some people look smarter than others, because they know these tricks. And now that you know it, you are as smart as them. Great. So we found for 30 degrees, we said this is the triangle, basically just repeating the same thing. Sine 30 degrees 1 over 2, cos 30 degrees is root 3 over 2, tan 30 degrees 1 over root 3, or if you rationalize it, you have root 3 over 3. Now for 60 degrees too, we've done that. Said root 3 over 2, for cos 60 degrees we have 1 over 2, and for tan 60 degrees we have root 3 over 1, which was the same as root 3. Now we're going to do for 45 degrees. So let me just move here. So for 45 degrees, let's draw another triangle, right? Or let me do a right angle triangle. So this is right angle triangle. It is an isosceles triangle. So this place says 90 degrees. If this place is 90 degrees, this side here too is 45 degrees, because this is a right angle isosceles triangle. So this is 45 degrees. And this checks out, because 45 plus 5 will give you 90, 90 plus 90 will give you 180. So this side here would be equal to this side, right? Great. If that is the case, if this place here is 1, this place here is 1, right? Great. So we can find this guy. So I could just say from Pythagoras, right? I'm going to write the equation again. This is the hypotenuse. Let's call it x. So this will be x squared is equal to the opposites. Anyone, this 1 squared plus and that 1 squared. So our x squared is equal to 1 squared plus 1 squared is 2. So our x is square root of 2. So this guy here is square root of 2. Right. So once you know this diagram, you can easily find your sine. So that they use the smallest values. They use the smallest values. If you look at that one, so they use the one for the 30 and 60, they use the smallest values. Right. So if they use 1, 1, 1, you'll be having half. No, so but they used 2, 2, 2. So that when you divide, you have an whole number. So sine theta is so opposite over hypotenuse. So you can say of this 45 degrees, the opposite of this guy is 1. The hypotenuse is root 2, so that is 1 over root 2. If I rationalize this will give me root 2 over 2, right? I've shown you how to do this. So the theta here is 45 degrees, right? So sine 45 degrees. So if I say cos 45 degrees, this is adjacent over hypotenuse, adjacent over hypotenuse, right? I still have the same thing. And what is that? Great. 1 over root 2 or root 2 over 2. So we have this. If I have my tan, so my tan 45 degrees, opposites over adjacent. So this is the opposites. You can use this guy. Opposites here is 1, adjacent here is 1. So 1 over 1 is 1. So this is how they were able to get all these values. It did not just jump from the sky. So you could see root 2 over 2, root 2 over 2, and 1. These are things that you should know offhand. If you don't need to find, just know the diagram and you can be able to find it. Know one diagram for 30 and 60 and know one diagram for 45 degrees. That's all. So we are here, and this says that sine 0 degrees is 0, cos 0 degrees is 1, tan 0 degrees is 0. You can press that in your calculator. Why is tan 0 degrees 0? Can anybody tell me? Great. Because tan is sine over cos. Remember we did that. And sine 0 is 0, cos 0 is 1. So 0 over 1 is what? 0. Look, and you see, there's a shortcut I still need to know this. Sine 90 degrees is 1, cos 90 degrees is 0, tan 90 degrees is undefined. Why is tan 90 degrees undefined? Beautiful, because anything divided by 0 is undefined. So I mentioned a diagram that, so this diagram I used to know it. And you can say I only put for here and here. We'll do for the other parts shortly and you will understand why. So what I just do is that I put my cross here and here I just say S is equal to 1, C is equal to 0. Here I can say S is equal to 0, C is equal to 1. So I just invert it. So whenever I'm doing it, I don't need to, from some things that make some people look smart once again. Once they say sine 0, they've very quickly done the cross. Sine 0, 0, cos 0, 1, right? They say, oh, what is sine 90 degrees? Sine 90 degrees is 1, cos 90 degrees is 0. Like, wow, how do you supposed to calculate it? It's just mental maths. Once you know your cross, you can be able to know that, oh, my sine 90 degrees is 1, cos 90 degrees is 0. Cos 0 degrees is 1, sine 0 degrees is 0. So once again, your cross, S is equal to 1, C is equal to 0. You know that is the inverse of this. So S is equal to 0, C is equal to 1. So this is for 0 degrees, this is for 90 degrees, right? 0, 90, 180 to 70, 360. We'll see what happened for 180 to 70, 360 shortly. So our trigonometry tables. How do you read from trigonometry tables? First thing is there's a trigonometry table that lists values for sine, cos, and tan for angles from 0 degrees to 90 degrees. You can check the back of a new general mathematics textbook or your forfeit table, you see this. So how do we do that? First is that we'll find the row, right? So we look up the main O degree or number in the leftmost corner. So maybe I'll just be doing it side by side. I took a screenshot from new general mathematics, the textbook. So step 1 says that we should do what? Find the row. Look up the main O degree or number in the leftmost column. So maybe I'll just comment. So this is the leftmost column, right? So I'll just comment for the sine. Or this for 0, 1, 2, 3, 4, 5, 6, 7, 8. So if I'm saying 30 degrees, we said sine 30 degrees 1 over 2, which is 0.5. So you can see 0.5 here. So this is the leftmost column. I'll locate that. Then find the column, right? Read across to your matching decimal column to get your base value. So if I was doing sine 53 degrees, so that would be, I will look for 50 here, then here I'll come to 0.3. So the value that it gives me, which is 7694, is what I need. Although it's not 7694, 0.7694, because you can see here, there is a 0 point. They didn't just write 0 0.0 0 0.0, so it's 0.7694. That's 53. It's 50.3, not 53. 50.3. If it was 53, I'll come to 53 under 0. That's 53.0. But for 50.3, I'll come to 50 under 0.3, which is 7694. Okay, so it now says find the difference. So if it was 50.34, 50.34, what do? I'll find the difference. So this is the difference. So 50.3, which is 0.7694. Then I'll come to this place that says difference of 4. See, 4 is 4. Then what is it telling me to do? Find the difference, add or subtract. So we add the difference for sine or log tables. I will subtract the difference for cosine tables. Value gets smaller. Theory. Let's solve some examples. So we're going to be solving an example using 63.35. So 63.35. So where do we go to? Let me go back. We go to 63, right? Beautiful. Under 3, what does it give us? 0.894. So that would be 0.894, right? Then this one says we should add, so plus 63.34. So 63.3, 0.8934. Okay, so that's my bad. So 0.8934. This should be 3 and 4, right? 63.34. Then we'll come to the difference. Under 4, it's 3.3. It says difference is 3. Difference is 3. We don't add the 3 like a whole number. No, you add it to the last decimal digit, so that is 3 here. So by the time I will now add, this will be 0.8937. 0.8937. And that should be our answer. So 0.8938. So we have 3 8. Let's see if we made a mistake somewhere. 63. Let me just get 63. Oh, it's not 34, 35. Okay, I think the mistake was from 63.35. 5 is 4. So this is 4, right? So we're adding 4, not 3. So 0.8938. Exactly what we have. So we have sine 14.52. So let's see, 14.52, sine 14.52. So we'll go to sine 14.5. That would be 0.2504. So let me just come here and see 0.25. Let me get this thing again. 14.52. So sine 14.52. So let me just say sine 14.52. So for 14.5, we'll go to 14, we'll look at 5, 0.2504, 0.2504 plus, we'll go to the difference of 2, 14.5, this is 2, so that's 3. So plus 3. And that will give us what? Great, 0.2507. Let's see if we're correct. Great. So you can see that there's a limit. If you have 14.523, the forgot table just gives us up just for 5 and then the difference for 2. I want you to do this one by yourself. Sine 42.18. Pause the video and try it out yourself. Don't continue if you have not done it. Welcome back. I'm sure that you did that, and that will be 0.6714 if you did that correctly. All right, so that's that about that. For cosine too, the same law applies, but you see here at the top, instead of add, you see the word subtract. If you add when you're meant to subtract, you're getting a different value. So I'll just do for this one, cos 44.74. Cos 44.74. So where will I be going to? Great. So 44 under 7 difference 4. Let's see that. 44 under 7, which is 0.7108. 0.7108. And a difference of 4, which is 5. Right. 44.74. So that will be minus, not plus here, minus 5. And that will give me 0.7102. 3. Let's see if we're correct. Great, 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 great. So I want you to do this one by yourself because 25.5 says I know I flashed the answer, but I hope you did not catch it. Try this out by yourself. If you did that, you should have 0.9021. Pause the video and try this one too out by yourself called 58.23. Remember, you subtract, you don't add. Pause the video and try it out. If you did that correctly, you should have 0.5266. 0.5266. I hope you got that correctly. So I mean, there might be a point difference sometimes, depends on your forgettable and this one, but generally your answer should be this. I mean, if you do it as a multiplication, the difference will be very minimal. So it could be 0.5 to maybe 67 in your own or something like that, based on, but just get your values correctly. For tan, right, same thing too, but here instead of subtracting, you add, just like you did for sine. So tan 35.45, as always, we do the first one together. So tan 35.45, tan 35.45. So tan 35, let's go back to the tan table. Tan 35. First thing, always look at, be sure that you are dealing with the right table. Don't go and look at tan when you must look at cos. So tan 35.4, which is 0.7107, 0.7107. Then because is I would add 35.45 is 13. So it says add, so I'm going to add plus 13, right? So if it's just one value, is the last guy. If it's two values, this guy, right? So the last two values. So this 0 carry 1 here, so this 2, 1, 7.0, so 0.7120. Let's see if we're correct. Great, great. So solve this by yourself. Tan 18.24, you can pause the video and try it out by yourself. If you do that correctly, you have 0.3296, and you can do this by yourself. Tan 52.67, if you do that correctly, you should have 1.311. Right. So the unit circle. this video is actually fully loaded. When you're done with this, you should be able to solve any question or trick. Then we'll look at angle of elevation and depression after we're done with all of this. So for angles between 0 and 360 degrees, what do we have? It says the XY plane is divided into 4 quadrants. The angles measured anti-clockwise. So clockwise is like, the way the clock goes, it goes like this. But anti-clockwise is like this. So measured as clockwise, and then the trig changes direction. So it goes like this. So it changes, the trig ratio change sign by quadrants. You see what that means? All this is just English. We have this, so anti-clockwise, so it goes like this instead of the normal clock direction like this. So we have CAST. You don't cast. So cast. What does that mean? Let's start from this A, and it's cast, right? So you don't cast. It starts from the A. A means all sine, cos, tan between 0 degrees and 90 degrees are positive. So this is 0, this is 90, this is 180, this is 270, and of course this is 360. So all angles between 0 degrees and 90 degrees are positive. All angles between 90 degrees and 180 degrees are negative except for sine. So only sine is positive. All angles between 180 degrees and 270 degrees are negative except for tan. And then all angles between 270 degrees and 360 degrees are negative except for cos, which is positive. So the ones that appear here at the positive values, this one says all of them are positive, only sine is positive, only tan is positive, only cos is positive. Great. Now, it says the sign of each ratio depends on the quadrant the angle falls in. So if I have a cos 120 degrees, is going to be negative. So you can press your calculator and see. So cos 120 degrees, that gives you minus 0.5. If I have a sine 250 degrees versus sine 250 degrees, it's going to give me a negative value. That will be minus 0.9397, right? Right. Now to this. So it says the cassoulet extends beyond 90 degrees. It extends beyond 90 degrees. So how do we do that when it extends beyond 90 degrees? So we said quadrant 1, 0 to 90 degrees, all ratios are positive. Quadrant 2, 90 to 180 degrees, sine is positive. If sine is positive, so look at this. There is a way I know this. I start with x, right? This is between 0 and 90 degrees, so that's fine. Between 90 and 180 degrees, of course, your value is already greater than 90 degrees. So basically what I'm saying is that if I have a sine 150 degrees, sine 150 degrees, you agree with me that it's going to be positive, right? Sine 150 degrees is going to be positive because it's between 90 and 180. But if in the exam I'm not given a calculator and I want to find what sine 150 degrees, you agree with me that it's going to be a bit harder. But what I can do is I can say 180 minus 150, that will give me 30 degrees. And if I do sine 30 degrees, that is 1 over 2, which is 0.5. And if you do sine 150 degrees, you also see that you have the same value, which is 0.5. On the flip side, if I told that the sine of an angle is 0.5, what is the angle? You agree with me that there are two answers for that. Is either it's 30 degrees or it's 150 degrees, based on what you just did here. So you can't just say, oh, certainly it is 30 degrees. You have to show why. And this is it, because x 180 minus x. So if it is greater than 180, that will be 180 plus x. And that is for tan. That is for tan. So if I have tan 30 degrees, which is root 3 over 3, and also have tan 210, you see that's going to give me root 3 over 3. So if the tan of an angle is root 3 over 3, and I'm told to find the angle, I can say that it could be what? 30 degrees, or it could be 210 degrees. So for cos, same thing too applies. If you have a value, right, 30 degrees, I know I'm missing 30 degrees, but cos 30 degrees and cos 330 degrees would give you the same value of 3 over 2. That will help you to think further, to know that there is most likely not only one correct answer, but in the option, it will most likely give you maybe one answer, a combination of all the answers. So quadrant 3, which is 180 to 270, tan is positive, use 180 plus x. Quadrant 4, cos is positive, 360 minus x. And then negative, if you have a negative angle, simply add 360 degrees to give you the positive equivalent. Carry a calculator again. Say cos minus 50 degrees. That gave me 0.6427. So if I add 360 to minus 50, that will give me what? 310, right? So cos 310, it still give me the same thing, 0.6427. You can try that with any negative value. It will give you the positive equivalent. So once again, we have x, 180 minus x, 180 plus x, 360 minus x. So it's just like, don't change. Negative, positive, negative. Cast. Last. Right. I mean, you can continue the song. So CAST. X, 180 minus x, 180 plus x, 360 minus x. And this only this applies to the guys that are here. So the sine, the tan, the cos. This picture of this cross should be nailed to your head. Nail it, crucify it to your head. All right, let's see some examples. So we're told that if theta is equal to minus 1 over 2, find all the values of theta between 0 degrees and 360 degrees. So for this, I'm not going to assume that we know any other thing. So minus 1 over 2 is minus 0.5, right? So we have our sine theta to be minus 0.5. So let's go to, let me just scroll back a bit to where we add our sine. So when we look at the sine, we had 0.5. So 0.5, right? 0.5 was for 30 degrees. 0.5 was for 30 degrees, right? So we can now say that if that was the case, just 1 second. Yeah. So if the theta from this was 30 degrees, 30 degrees give us 0.5. But what we have here is minus. So in which quadrant is sine negative? This is how you solve the question. In this first quadrant, sine is positive. In this next quadrant, sine is positive. But in these two quadrants, sine is what? Negative. So you just come here and say, in this place, this would be 180 plus x, which is 210. And this place, this 360 minus x, which is 330 degrees. So you see where all these 180 plus x, 360 minus x, and 180 minus x really coming. Right, so you need to snap it at the back of your mind. So you can see that there are multiple values, right? So I mean, 30 degrees applies for it applies for all these guys, but based on the sign, you should know that it is just these two, right? The absolute value, which is positive value, is 0.5, 0.5, 0.5, 0.5, but because of it falls in the T and C quadrant, it's going to be a negative value because only tan and cos is positive here. So our answer here is 210 and 330 degrees, which is option C. I hope you understood what I said. If we did not, let's look at the next example. Okay, so there's only one example here. Yeah. So let me just give you one other example. So if our tan theta is let's say minus root 3 over 3, minus root 3 over 3. Remember, we got the minus root 3 over 3 from 30 degrees, right? We said tan 30 degrees is root 3 over 3, right? That's what we had this, but now it's a negative value. So minus root 3 over 3. So what are the values of theta here? Can you tell me? If our theta that gave us root 3 over 3 is 30 degrees, what are the ones that give us minus? Have you gotten it? Beautiful. So that would be 150 and what? 330. So you can press a calculator, that would be tan 150, so that will give you minus 3 over 3 and minus 330. That will give you minus 3 over 3. So once you know that, just come and apply it. So remember your x, that's why you need to know your cross, right? Nail it to your head. Nail it, nail it, nail it, nail it, nail it until it enters. X degrees, 180 minus x, 180 plus x, 360 minus x. Now we're coming back to the special angles. We established the fact that sine 0 is 0, right? Cos 0 is 1, tan 0 is 0. We also established the fact that um, for the for the 90 degrees established. But what I also want to put in place is that the same thing that applies for 0 degree also applies for 360 degrees, because if I'm coming this 0, this 90, this 180, this 270, of course it's going to be 360. So our sine is also 0, our cos is also 1, our tan is also 0. Now also the other side of it, right? If you put our casts C, A, S, C. The same thing too, our C is also, the positive value is 1, our S is also 0, but here the value is actually minus because here cos is negative, only sine is positive. So that's why it's minus 1 and 0. I hope that makes sense to you. So you see the same absolute value, but in terms of sign, it will change because of this cast. 90 degrees, we've established this one that sine 90 degrees is 1, cos 90 degrees is 0, tan 90 degrees is undefined. So the same thing will happen here, but here the sine of 270 will be minus 1 because here, this place here, only cos is positive. So our cos is still 0, cos 270 degrees is 0, and our tan 270 degrees is still undefined. So we have the full picture of our plus. So we have our plus, s is equal to 1, c is equal to 0, s is equal to minus 1, c is equal to 0, s is equal to 0, c is equal to c is equal to 1, so this plus 1, and s is equal to 0, c is equal to minus 1. Then these are c, a, s, t. In terms of the values, this is x, this is 180 minus x, this is 180 plus x, this is 360 minus x. Please let it stick in your head. Great. So we're going to reciprocal ratios. Every trig ratio has its reciprocal, and I mean they appear in identities, and you could see them in your exam question. So I mean, what we have cosecants, secants, and cotangents. We have cosec, cot, and sec. So what are all these things? It's just listen. So sine. If I have look at this, and this is the way I got to know it. 1 over tan theta is cot. So t cot. 1 over cos theta is sec c. I know that the cosec did not follow, it did not align with it, but 1 over sine theta is cosec. So 1 over sine is cosec, 1 over cos is sec, and 1 over tan is cot. It's just the inverse. If so is opposite of hypotenuse, then cosec will be hypotenuse over opposite. And if cos is adjacent over hypotenuse, sec will be hypotenuse over adjacent. And if tan is opposite over adjacent, cot will be adjacent over opposite. That's just reciprocal, basically. Once again, 1 over sine is cosec, 1 over cos is sec, 1 over tan is cot. Great. That will lead us to trig identities. What are trigonometric identities? I think this video is loaded. Wow. So identities are equations that are true for all values of theta. So they are true for all values of theta. And they're used to simplify and solve expressions. And they're derived from the Pythagoras identities, which is a squared plus b squared is equal to c squared. We know this already. So a squared plus b squared is equal to c squared. These are the legs, and this is the hypotenuse. The core identities to master. Once you know this, you're good to go. Sine squared theta plus cos squared theta is equal to 1. We've established that, yes or no? 1 plus tan squared theta is equal to sec squared theta. How did we arrive at this? So look at this. We had sine squared theta plus cos squared theta b. So if I have sine squared theta plus cos squared theta is equal to 1. And I divide all through by cos squared theta. Sine over cos is tan, right? So this will be tan squared theta. Okay, so this should be plus cos squared theta over cos squared theta. This will cancel each other, is equal to 1. 1 over cos is what? Beautiful sec, right? So sec square theta, because it's square. So these are the idea tan squared theta plus 1 is equal to sec squared theta. And of course, if I divide through by sine squared theta this time around, so if I say sine squared theta over sine squared theta plus cos squared theta over sine squared theta is equal to 1 over sine squared theta. So the same equation, this is our sine squared theta plus cos squared theta is equal to 1. This time around, I divided it by sine squared theta. This will cancel, this will be 1. So this will be 1 plus sine, cos over sine. Right. You know, normally sine over cos is what we have as tan, right? But this time around is now being inverted. We have cos all over sine, and cos all over sine is our cot, COT, so cot squared theta, because we said 1 over tan is cot, right? So this is like 1 over tan basically. is equal to 1 over sine square theta. 1 over sine is what? Cosec. So cosec square theta. So we have 1 plus cot square theta is equal to cosec square theta. So basically, you just need to know this one, the first one, and you are good. Now, one other thing I want to know is that sine theta is equal to cos 90 minus theta, and cos theta is equal to sine 90 minus theta. So, I mean, if two angles sum up to 90 degrees, they are complementary, right? Great. So, um, if I have sine 30 degrees, sine 30 degrees will be equal to cos what? Beautiful, cos 60 degrees. And if I have cos 45 degrees, that will also be equal to what? Sine 45 degrees. Remember, this was what we had when we did the what we're trying to prove it, if you remember. So, and that gave us root 2 over 2. Remember that time. So once you have this, these are small, like I said, these are small things that make some people look very smart. You just know these things, and they like to think, and it comes from practice, practice and practice. You are as smart as them, even smarter, but you just need to just put in the work. Now, we've discussed that tan theta is sine theta over cos theta, which is tan theta. And then if I invert it, that will give me cot theta. So cot theta is cos theta over sine theta. Let's see some examples. This one says that if 30 degrees is equal to 0.5, what is the cosine of its complement? Big English. Complement is 90 minus the angle. 90 minus the angle, which is 30 degrees, and that will give you 60 degrees. So what is cos? Yeah, cos 60 degrees, right? And we know that sine 30 degrees is equal to what? Cos 60 degrees, right? Because of the complementary rule. So definitely, without even putting pen to paper, we know that our answer is 0.5. But if you don't know this, you'll be lost from the word complementary. And this is one, I think, is a WAEC question. So our answer is C, 0.5. Complement means this sum up to 90 degrees. Right, so if one is 30 degrees, the cosine of the complement, which is cos 60 degrees, is still the same thing. Look at this now. So it says if sine x is equal to cos 50 degrees, then x equals what? This is from WAEC 1993. X equals what? Without even punching a calculator. We know that it's going to be 40 degrees because of the complementary thing. So that would be 90 minus 50 is 40. So sine 40 is definitely equal to cos 50 degrees. Correct. See an example. It says that given that cos theta is equal to 4 over 5, find the value of 1 plus tan square theta. So we know cos theta is equal to 4 over 5. I'm going to find 1 plus tan square theta. Is that not it? But we know that 1 plus tan square theta is equal to what? Can you remember? Sec square theta. If you don't remember, it just starts from the beginning. Sin square theta plus cos square theta divided all through by cos theta, right? Divide through by cos theta, and you get this. Given this, the next thing that I would look at is, we know that sec square theta is what? 1 over, what is that? 1 over cos theta. We know that. So this is like saying 1 over cos theta all squared, basically. And the question is that we should find 1 plus tan square theta. So basically, we've broken this down. Since we know that sec is 1 over cos, right? Sec is 1 over cos. We just said 1 over cos theta all squared. And I'll give you 1 divided by 4 over 5 all squared, or 5 over 4 all squared. 5 times 5 is 25. 4 times 4 is 16. So answer is 25 over 16. Simple. Just by knowing that sec is 1 over cos, cosec is 1 over sine, cot is 1 over tan. So 25 over 16. Great. So we have the inverse trig ratio. So You know the way when I wanted to find 0.5 for the sine, I said, oh, what will give me 0.5? I went back to the table and I said, okay, I chose to 30 degrees. There's something called sine inverse. And if you use a calculator, you will have seen it. To get the sine inverse, just press the shift button on your calculator and press sine. So shift and then the sine is to give you the sine inverse. So if you know the results, you can find the angle. Basically, so just use to find the angle when the ratio is known. So you can use trig tables in reverse, like I did, right? Like I did, or you can use your calculator using the shifts and the maybe cos or tan or sine. And then you should always check the quadrants to find all solutions. Remember, from our casts, it's not necessarily going to be only 30 degrees. There can be also something else too. Right, so remember our casts, EST, remember the 180 minus x, 180 plus x, 360 minus x. So if you look at this example, it says that if sine theta is equal to 0.5, then theta is equal to, so I mean, just take a calculator and do sine inverse of 0.5, you get 30 degrees. But does that mean that it's only 30 degrees that can give you this? No, look at your casts, right? 30 degrees falls there. That's why all of them are positive. Sine is also positive here. So apart from this 30 degrees, you also have where it could be 180 minus 30 degrees. So let me just get my pen and I'll give you 180 minus 30, right? And I'll give you 150 degrees. So x could be 30 degrees, x could be 150 degrees. This is why you need to know your cast very well. Right, so if cos theta is equal to 0.866, so if we do cos inverse of 0.866, that will give you 30, right? 30.00 something. So it's positive, right? So it's still within this place. So it could be 30 degrees, or where else is cos positive? Cos is positive here, or 360 minus 30 degrees. So either your answer is 30 degrees or 330 degrees. So it's either one of these two would give you 0.866 as your theta. Great. And if your tan theta is minus 1.000, so let's do the positive. I say tan inverse of 1. Let's do the tan inverse of 1. So we have 45 degrees, right? So 45 degrees, if I do tan 45 to give me 1, right? Also, you know that from our triangle normally, if you do tan 45, you have 1. But what you have here is minus. So in this case here, where is tan negative? Tan is positive here, tan is positive here, but tan is negative in these two places. So I could say 180 minus 45, which will give you 135 degrees, or 360 minus 45, which will give you 315 degrees. So either 135 or 315 degrees. So this is basically ways to go about this. So for this one, I want you to try it out by yourself. So if cos theta is equal to minus 0.5, then theta is equal to, pause the video and try it out by yourself. If you're done, you see that your answer is 120 degrees or 240 degrees. Great. So now let's look at more examples on all of the things that we've been talking about. Are you ready? Let's get started. So for the first one, it says a right triangle has a 45-degree angle and a hypotenuse of 4. Find the opposite side x. Find the opposite side x. So for this, I mean, if you want to try it out, you can pause the video and try it out by yourself, and you can continue watching to see what I've done. So we have our triangle here. Let me just do a triangle. Is a right triangle, right? So this guy is 45 degrees. Obviously, so that guy here will be 45 degrees. So it says the hypotenuse is 4. Find the opposite side x. Opposite side x. So what do we know about all these guys normally? So if this place was this place will be 45 degrees, right? So our normal triangle, we know that this place is 45, this is 90 degrees, this place will be 1, this place will be 1, and this place will be root 2, right? So we could say this is opposites and hypotenuse. So that's sine. Sine 45 is equal to x over 4. And from here, we can know sine 45 to be equal to what? 1 over root 2, right? Great. So if I cross multiply, that will be x root 2 is equal to 4 times 1, which is 4, and divide by root 2. I've then rationalized. This will be multiplying the top by root 2, multiplying the bottom by root 2. So that will be 4 root 2 all over root 2 times root 2 is 2, so 2 here 1, 2 here 2, and that will give me 2 root 2. So that's the value of our x. So answer is 2 root 2. Let's see if we're correct. Great. Example 2 states that without tables, evaluate 1 plus tan 60 degrees times tan 30 degrees all over tan 60 degrees plus tan 30 degrees. So for this, I'll just draw my reference triangle. Right, this place is 60 degrees. This place is 30 degrees. This is a right angle. All right, this side is 2, this side is 1, and this side is root 3. You remember from what we have done previously. So this will be 1 plus tan 60. This will be opposite over adjacent, right? So tan 60, this is opposite root 3 all over adjacent. That will be root 3. Great. And then our tan 30, this 30 degrees opposite over adjacent. So that's 1 over root 3. Great. So we have 1 plus root 3 times 1 over root 3 all over root 3 plus 1 over root 3. So this will cancel this. All right. You'll be left with 1 plus 1 here all over open bracket root 3. So these root 3 root 3 divided by 1, that will be root 3 times root 3, that will give you 3. Root 3 divided by root 3 will give you 1. 1 times 1 will give you 1. So we have 1 plus 1, which is 2 all over 4 over root 3, right? So we have 2 times root 3 over 4, right? If I just do the division, I skip the step. So that will be 2 here 1, 2 here 2. So your answer is root 3 all over 2. Let's see if we're correct. Yeah, so we say our 30, 60, 90 degrees triangle, root 3 over 2. Example 3 states, given that x is equal to 5 over 13 and x is between 0 and 90 inclusive, find cos x minus 2 sine x all over 2 tan x. So this is one trick. There's one trick, right? There's some common angle of side. So you could have something, you could have 5, 12, 13. These are some very common things. I think we have 3, 4, 5, and the multiples of it. So you could have 6, 8, 10, right? You could have 9, 12, 15, right? So multiples of these guys. I think these are the most common ones, apart from our 1, 1, root 2 for 45 degrees, right? But for 30, 60 degrees, these are very common angles, right? So these are 60 degrees. These also are 60 degrees. So we're told that if sine x is equal to 5 over 13, so 5 over 13, sine, that would be opposite over hypotenuse. So you can see 5 over 13. So 5, 12, 13, 3, 4, 5, multiples of these guys. So you could have 10, 24, 26, right? That is multiplying each of them by 2. So these are very common things. So from here, we know that our cos x is adjacent over hypotenuse. So the adjacent is 12, the hypotenuse is 13. So that will be 12 over 13. And then we know that the tan of x will be opposite, which is 5 over adjacent, which is 12. So that will be 5 over 12. So now let's substitute. That will be 12 over 13 minus 2 times 5 over 13 all over 2 times 5 over 12. So this will give you 12 over 13 minus 10 over 13 all over, so just do this, 12, 2 times 5 is 10. So 12 over 13 minus 10 over 13 will give you 2 over 13 divided by 10 over 12, and this will give you 2 over 13 times 12 over 10. So 2 here 1, 2 here 5. So this will be 12 over 65. So if you have done this correctly, your answer should be 12 over 65. Let's see if we're correct. Great. Example 4 states that given that tan x is equal to 5 over 12, find the value of cos x plus sine x, or find the value of sine x plus cos x, any how you want to put it. So remember I told you, right, there's some common angles, right? This is one of them. So this is where the 1 of 5, 12, 13 comes in. So we have something like this. This is 5, this is 12, and this is 13. You can take it to the bank. So 60 degrees that I should with 60 degrees. So if tan x 5 over 12, so tan is opposite over adjacent, right? 5 over 12. So sine x will be what? Which is opposite over hypotenuse, which is 5 over 13. And then our cos x will be equal to what? Which is adjacent over hypotenuse, 12 over 13. So let's add 5 over 13 plus 12 over 13. And I'll give you 17 over 13. Let's see if we're correct. Great. Question 5 now says that if sine theta is equal to root 3 over 2 and cos theta is equal to minus 1 over 2, find the value of theta. So sine theta is root 3 over 2. That means the sine value gives us a positive value. So if you draw a cast, C-A-S-T, right? The sine gives us a positive value, right? But the cos gives us a negative value. So it's between 90 and 180, right? So I do know that. So 90 and 180, right? So let's see. So if I have my triangle here, and this is the theta, sine is opposite of hypotenuse, so the opposite is root 3, the hypotenuse is 2, cos is adjacent of hypotenuse, so the adjacent here is 1 over 2. So if you look at this, this is 1, 2, root 3. We have something like this before. Yes, when our theta is what? 60 degrees. Remember that our triangle. So these are some common things. 1, 2, root 3. Once you start seeing this, you already know that it's talking about theta at 60 degrees. But in this case here, we said our theta is between 90 to 180 degrees, right? And for that second bracket, which is this C-A-S-T, can you remember the formula for the second one? Can you remember? Beautiful. So that's 180 minus x, which is 180 minus 60, which is 120 degrees. So our value of theta is 120 degrees, because that's the one that will satisfy this condition of negative. Great. Example 6 says that if theta is equal to 3 over 5, find tan theta where theta is between 0 degrees and 90 degrees. So it's still following with one of these. So let's just draw it. So we still have this. Remember, I think one of it was 3, 4, 5. So 3, 4, 5, right? And this is 60 degrees. Can take it to the bank. 60 degrees. So if the sine, which is opposite, okay, so now opposite over hypotenuse. So the opposite is meant to be the one of 3, right? So this way you have to now be very careful. So let me just reword it. So it's 3, 4, 5, but the location of the 3 and 4 might be different, but the location of 5 will always be the hypotenuse, because that's the longest side. So this is 60 degrees, the opposite is 3, the hypotenuse is 5, so of course this is the one that is 4. So it said we should find tan theta in this case. So this is a trick question. Don't just say this supposed to be 3, 4, 5. Let the question guide you. So tan, which is opposite of our adjacent, this will be 3 over 4. So our tan theta is 3 over 4. Let's see if we're correct. Great. Example 7 says that if cos theta is equal to 5 over 13, find tan theta where theta is between 0 degrees and 90 degrees. So these are triangle, of course. When you're using 5, 12, 13, so you know that the adjacent is the one that is 5, the hypotenuse is the one that is 13, and this guy is the one that is 12. All right. I think the previous questions I always just assume because you followed pattern. That last one opened my eye. So this guy is 60 degrees. So find tan theta. Tan theta is 12 over 5. Right. So let's see if we're correct. Great. Example, it says that if tan theta is equal to 2 whole number 2 over 5, find sine x where your x is between 0 and 90 degrees. So we can also use this one, right? If you look at the example, say tan x is, if you make this an improper fraction, this will give you 5 times 2 plus 2, which is 12 over 5. So your tan x is basically 12 over 5 from here, which is what we found in this previous question. So our sine x, what is what we should find, is opposite of hypotenuse, which will be 12 over 13. Great. Example 9 says that without tables, evaluate sine 20 over cos 70 plus cos 25 over sine 65. I want you to actually pause the video and try this out. So I want to see if you remember something we talked about. Welcome back. Let's get it together. Remember we said for complementary angles that sine theta is equal to cos 90 minus theta, and we said cos theta is also equal to what? Sine 90 minus theta, right? So yeah, see, this is sine 20 cos 70. These are basically the same thing, right? Because 20 plus 70 will give you 90, complementary. So this is like saying sine 20 degrees all over sine 20 degrees plus 25 plus 65 will give you 90. So you see the same thing that applies there. You could say cos 25 degrees all over cos 25 degrees, right? I could just replace this guy with cos 25 degrees because it's the same thing. So this guy will cancel, we have 1. This is cos here. So you have 1 plus 1, which will give you 2. Simple questions like this can make somebody look like a genius. Let's see if we're correct. Great. Example 10 says that if sin theta is equal to cos theta, find all the values of theta for theta between 0 degrees and 360 degrees. So if sin theta is equal to cos theta, find all the values of theta for 0 degrees, for theta between 0 degree and 360 degrees. So for this one, I want you to try your hands on it. Let's see what you can come up with. So pause the video and try your hands on it. Great. So, we said something. This is more of a logic question. For this to happen, I'll just do it here. We said sin theta is equal to cos 90 minus theta. So for these two guys to be the same, what do you think needs to happen? Right? If theta is 45, that will work. So sine 45 would be equal to cos 45. But let's also see if we use cast, there will be a place where both sine and cos would be equal, apart from this first guy, right? Would there be a place where sine and cos would be equal in terms of sine? Yes, sine would be negative, cos would be positive, so that would not work. Yeah, tan would be positive, but sine can be negative and cos can be, or not even can be, cos is negative, sine is negative, so they will still be the same value, right? Just be minus minus. Yeah, cos is positive, sine is negative, so this one cannot work. So the only place where it is, we have 45 degrees, and in this place, what did we say we were going to do? Can you remember? Great, we said 180 plus theta. So that would be 180 plus 45, and that would be 225. So the only place where this would happen is when theta is 45 or 225 degrees. You can see all these casts really coming in, right? And those two values are between 0 and 360 degrees. So you can say answer is 45 degrees or 225 degrees. Example 11 says that if sine x is equal to 12 over 13, x is between 0 and 90 degrees, find the value of 1 minus cos square x. I want you to actually pause this video and try it out by yourself. Welcome back. So I'm not going to solve it, right? So you already know your triangle. This is 12 and 13. So from this, the opposite is going to be 12, the hypotenuse is going to be 13, and the other side is going to be what? Great, 5. And from our identity, we said sine square x plus cos square x is equal to 1. So if they said you should find, or let's make sine square x of the formula, this would be 1 minus cos square x. And it says you should find 1 minus cos square x. So, and you have sine x. It's just to square it, basically. right? I mean, 1 minus cosine sine square is already have sine x, just square it. That'll give 144 over 169. Great. You don't even need to even do anything for that one. Example 12 says that given that sine A plus B is equal to sine A cos B plus cos A sine B, evaluate sine 105 degrees in surd form. So when you see the word in surd form, you should already go to your diagram, the diagrams that we know. Those are the ones that actually give you the results in surd form. Right? And this is sine 105. You can break this 105 to two things. You can break it to 45. You can break it to plus 60. Can we find sine 45? Can we find sine 60? Yes, we can. Can we find cos 45? Can we find cos 60? Yes, we can. So you just apply it. Let's have it together. So we said this is something as saying sine 60 plus 45. So automatically this guy becomes our A and this guy becomes our B. So this would be sine 60 multiplying cos 45 plus cos 60 multiplying sine. So this does not look like multiplication. So let me just make it look like multiplication. Multiplying sine 45, right? So I'm not going to draw it. You should know what sine 60 is. You can always use your the table. So sine 60 is root 3 over 2. So this is root 3 over 2. So what is cos 45? By the time we do your triangle, great, that's root 2 over 2 plus cos 60. What is cos 60? Great, 1 over 2 multiply what is sine 45. By the time we do that, that will give you what? Root 2 over 2. Great. So root 3 times root 2, that will give you root 6. All over 2 times 2 will give you 4. Plus 1 times root 2, that will give you root 2. All over 2 times 2, that will give you 4. So you can just see this is like saying root 6 plus root 2 all over 4. So this is actually your answer. Root 6 plus root 2 all over 4. Right. Yeah. I mean, don't go and say root 6 plus 2. That is something entirely different. Entirely different. And very wrong. So the answer is root 6 plus root 2 over 4. There's no way I can break down any of all these guys inside. 6 is 6. 2 is 2. I can't break it down any further. Let's see if we're correct. Great. As hypothesis says that if theta plus I don't know what this guy is. Right, so symbol A plus symbol B is equal to 90 degrees. Simplify sine theta plus sine whatever square minus 2 sine theta sine let's say theta or something. I think this theta, I don't know. Let's see if we're able to solve it. I want to actually pause the video and at least try this out yourself. It's a very logical question, so try it out yourself. So what do we have here? Theta plus file, let's call this file, is equal to 90 degrees. So what you can see here is complementary. That is the first thing you need to note. They're complementary. If I break this down, I'm not going to solve this, right? I mean, you should know how to open up a bracket. We've done this before. So this would be sine theta plus 2 sine theta sine file plus, so this is, sorry, sine square theta plus sine square file, right? This would be the, if I open this up, this is what I will have, minus 2 sine theta sine file, so plus 2 sine theta sine file minus 2 sine theta sine file, they will cancel themselves. I'll be left with sine square theta plus sine square file, right? Sine square theta plus sine square file. What can I see from this? Since theta plus file is equal to 90 degrees, do you agree with me that when we also know that from complementary, this is why I love this question, because it ties a lot of things that we've done before. So we say sine theta is equal to cos 90 minus theta, right? And from here I could say phi is equal to 90 minus theta. Is that not it? Right, so I mean I could just say sine theta is equal to cos phi. Is that not it? Great. So if I say sine square theta, that is like saying cos square theta, cos square phi, right? Plus sine square phi. Is that not it? I know that from identity, what do we say sine square theta? So if I say sine square theta plus cos square theta, what would that give me? 1. So that means this guy too, I mean cos square phi plus sine square phi. This should be equal to 1 too. So cos square phi plus sine square phi is equal to 1. Simple. Just know your rules, and take note of things. They always point us the question. Look at this. This is the pointer. If you miss this one, every other thing, you just struggle with the question. Let's see if we're correct. Great. So this is the end of today's topic. See you guys in the next video. Bye for now.